Hello, I am finally back to working on the Aleph 3 clone project, and it's been a busy summer and just haven't had a whole lot of time. So as you can see, I am still pursuing the fan heatsink tunnel idea. This is what the backside or the vent side looks like. I am pushing air through this direction, going this direction through the tunnel, and I have printed up a little bracket here that holds the fan. My son did the CAD work, and all I did was print them. This is what it kind of looks like. As we can see, I'm using two of these Aleph 3 clone modules. So this amplifier is stereo, and this has to dissipate a whole lot of heat. If you look at the Aleph 3 manual from past laboratories, they state that their amplifier dissipates 250 watts. Now, this is a Class A design, so we need to remember that it is going to dissipate 250 watts all of the time, and the amplifier in its idle state is going to dissipate 250 watts. I was planning on using two of these XP Power LCS 150 power supplies, and I'm going to run them in series to get my plus minus 24 volts. I believe the past design runs off of 24 or 23 volts in the inside, and so that was my original target. I did run into a couple of issues, and you can see I've got a different power supply here, and this is the XP Power LCW 150. It has the same power rating as the LCS. However, it costs a little bit more money. This is the startup current of the Aleph 3. This is a single Aleph 3 board, and this trace is the current coming out of the power supply, and here is the voltage. And this time base is 100 milliseconds, so from here to here is approximately half a second. And we can see that this current spike is 6.3 amps, and after about a half a second it settles down to roughly 2.5 amps. This is its idle current. This 6.3 amp surge will be doubled with two of the boards, so about 12.5 amps. LCS 150 is not capable of supplying 12.5 amps for this short amount of time, and it goes into a protection mode, and it will just sit there and cycle on and off, and the amplifier and the power supplies will never be able to turn on and get to a steady state. My second hiccup I've encountered is heat. I am not able to get rid of enough heat to run the system at plus and minus 24 volts. I could do it if I had a much higher speed fan here, but then that fan would be really noisy, and you wouldn't want to have that fan going so fast and loud. I have decreased the voltage of the XP power units, and I think my sweet spot is going to be plus and minus 20 volts. I will show this on my computer desktop, but what I've done is I'm showing 3 different voltages here, how much power is the whole system is drawing, and what my temperatures are at 3 key points. The one I'm going to focus on is the screw head of the heatsink attachment to the transistor right here. And at 20 volts, I am roughly 71C at 20 volts. And you can see at 22 volts it's 76, 18 volts it's 67 degrees C. At 4, this row 4 would have been at plus minus 24. Now another reason why I've switched to the LCW power supplies is that the LCS cannot be trimmed down to 20 volts. It can be trimmed down to about 21 volts. These power supplies have a little small trim pot here, and on the LCW you can trim this to maybe 21 volts, maybe up to 27 volts, maybe a plus minus 3 volts. The LCW has a much wider range of trimming, and I can trim it down past 18 volts. To illustrate how loud the fan is, I'm going to plug it in while I'm talking, and you'll be able to maybe to determine or hear the fan to see how loud it is. I might do a few more experiments with some different types of fans to see if I can get the same efficiency with maybe a quieter fan. I've got the system turned on. It's been on for maybe about 15 minutes. It takes maybe 20 to 30 minutes to get to its steady state temperature. My room is actually fairly cool. You might be able to read that. We're about 20 degrees C. I have a 8 ohm load attached to each channel here and here, and both channels are in parallel and being driven by the audio precision unit here. Right now my output is off, there's not a little orange LED lit up here. To achieve a full output to where the output's just below clipping, I have an input of 1.3 volts. You're probably not going to be able to read that. I'll zoom into that a little later. Currently we have approximately 237 watts are being drawn from the wall. A majority of that power is going to be dissipated in this heatsink. These power supplies are around 90% efficient. I'll have to double check that. So, there might be 20 watts or so being dissipated over here. So the funny thing with a Class A amplifier like this is you can see that we've got 237 watts coming from the AC mains. I'll turn on my output here. So now the amplifiers are running at full capacity, and you can see that our power drawn from the wall did not change. The amplifier has been on for probably about 30 minutes now, and it has reached a steady state thermally and hot enough that I don't want to touch that for more than a second or so. I've got my thermometer sitting here, and I've put my little watt meter over here so you can see the input power to the amplifier. I'm going to put my probe on the top of the TO-247. Right now my generator is off. We don't see the yellow LED here, and we also don't see the signal here. I have both channels being driven by the same channel. So we're roughly 70 degrees right now. I'm going to turn on the generator You can see that the AC power draw did not change at all. And we can see that the amplifier is starting to get cooler. We're dissipating some of the heat that was here now into the speakers, or in my case, the loads. Right now our peak voltage is about 18, almost 19 volts. My audio precision unit says that our output is 13.2 volts. Scope is saying about 13.5 volts. That's RMS, and if we square that and divide it by 8, we're roughly 23 watts. I am going to detail the power supply and thermal issues of the project. So I started with the XP Power LCS 150. XP Power is my go-to power supply company. They have always been reliable, and they have always met their compliance specifications. The LCS 150 is a very economically priced power supply, and it is capable of 6.5 amps at 24 volts. The PAS amplifier modules require about 2 amps each, so that's 4 amps total, so we should be good. I hooked up the two power supplies in series to realize the plus minus 24 volts, and the little status LED indicator on the power supply started cycling on and off when we first turned on the amplifiers. The power supply overload protection is 150%, and it's a hiccup continuous mode. So 150% of this, so we shouldn't be triggering this protection mode until we hit about 10 amps. So I disconnected one of the channels and hooked up a scope probe and a current probe and looked at our inrush current into the amplifier, and it is approximately 6.3 amps and lasts a few hundred milliseconds until it settles down to 2 amps. This is the 24 volt rel out of the power supply. So 6.3 times 2, 12.6 amps. We are way too high, and so that's what's happening. The hiccup mode, the little LED, it just starts cycling on and off, and the amplifier was never able to turn on. I spoke with XP Power. They suggested the LCW 150, and it is very similar in power and current. It is 6.3 amps, 24 volts, 150 watts, but they suggested that it might work better because its short circuit protection on this supply is constant current mode. So it will just limit itself to its maximum current and just keep on going. And it does. So this is the LCW, and I've got two of the ALIF 3 modules running in parallel or stereo. And we first turn it on, and we can see what looks like to be their constant current mode, kind of cycling on and off for a few hundred milliseconds, and eventually the power supply current falls here as the amplifier wakes up and starts running. So I think this looks good, and you can hear this in the power supply. You hear a little beep as it's doing this. Okay, so that is all working. The LCW 150 does cost a little bit more money than the LCS 150. Okay, so we're going to look at the thermal, and running the plus minus 24 volts, the amplifier was getting just way too hot. So the power supplies have a trim pot that is right next to the connector, and you can see it here on the LCS 150. However, the LCS 150 can only trim to a 21.6. That's down from the 24, and that's not low enough. Interestingly is that the LCW also says that it can only trim to 21.6. I was able to adjust that pot all the way down to 18. However, we're going to shoot for 20 volts. So I adjusted both power supplies to a 20 volts to get my plus minus 20 volts. And that gives us this data here, where the total draw of the system is 232 watts. I got a V peak of 18 volts and a RMS power of 23 watts. I think we're safe at this voltage. We'll have to do a little bit more testing. Note that the PAS ELIF 3, the one you could buy years ago, is rated at 250 watts, V peak of 23 volts and 30 watts. We could do that with these modules. We would just need more heatsink and or maybe more airflow. The signal looks good. When I increase my voltage here and I go into clipping, I don't get any nasty looking stuff. Pretty much the top and the bottom just get flat. I think our thermal characteristics are going to be okay for a plus and minus 20 volts. I might do a couple more tests with some different fans to see if I can get a little bit more airflow and keep the audible noise of the fan down. That's about it. Next video we'll try to get this all into an enclosure. Thanks. Bye.